Hey, welcome back, Bugs and Grills. We are going to talk about arithmetic and geometric series today. And if you're thinking, what the heck is a series? I'm not talking like Dragon Ball or Naruto or whatever it is you're into watching. But I'm not going to tell you right now because it's on the next slide with the vocabulary. You feel me? So, we are going to be able to find the sum of the first n terms in a sequence using a formula. And when I say n, remember n is just a natural number. And natural numbers are the numbers that you count with, right? It's like 1, 2, 3, 4, ... you know? It's just counting numbers. Cool? So we're going to find the first however many terms added up. And now that I've spoiled this prize, let's go check out the vocabulary. So check this out. Vocabulary in symbology. I might have made this word up, but maybe not. Probably not, but I'm going to tell you I did because it'll make me feel good. So first, you need to know what the word sum means. Not to be confused with the word sum, meaning like a little bit of. Sum with a U in the middle. This means when you add numbers up. Sum is the addition of numbers, right? For this lesson, you need to realize you can add negative numbers together, but it looks eerily like subtraction. Sometimes I tell kids that there's no such thing as subtraction, and then they give me one of those kind of like, looks. You know what I mean? They're like, what'd you just say? There's no such thing as subtraction. If you think real hard about it, you're just adding negative numbers. You're not subtracting. So, sum is when you add up numbers. A series is a special thing in math. A series is the sum of the numbers in a sequence. So if we have our favorite sequence, let's say it starts with 7 and we add 13. Wait, hold on. There we go. Add 13. I can do math. To turn this sequence into a series is super easy. Watch this. Now it's a series. That's the only difference. A series is when you add up all the numbers in a list. Okay. You are also going to see a fancy symbol today. It's this symbol right here. This is the Greek letter sigma. Please refrain from making any jokes by replacing the first letter of this word with any right-angled letters. That would be immature and childish of you to do, so please don't. We don't do those sort of things around here. Math is very serious, and we don't make any jokes about replacing S's with L's. What this symbol tells you to do in math is it says add up all of these things. So instead of writing this plus this plus this plus this, they'll use this symbol to do the shorthand so that they don't actually have to write everything out. And I'll kind of explain the notation a little bit better on the next slide. So let's go check that out. So we have two formulas that you are going to need to use. And I've actually copied them onto the next slides with the examples so that you don't have to, or rather I don't have to go bloop, 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 and make you seasick by flipping back and forth. So let's kind of break these down. So we're going to just focus on the left half of this for right now. Let's just look at this fancy thing because it's a lot to digest. This is like one of those like really big meaty burgers with a lot of savory stuff on it. It's like dripping juices all over. We got to break this thing up, clean it up so we can tell what we're chewing on. So obviously we have the sigma. All that's telling us is that we're going to have something plus something plus something plus something. Okay. On the bottom here, we have I equals 1. And this I is not the imaginary I. This I does not equal the square root of -1. It's a different I. It's just what they use in textbooks for some reason. So it says I equals 1. Then we have an N on top. This is telling you which numbers you are adding together. This tells you where to start, and this tells you where to end. All right? So it's saying I starts at 1 and then goes to n. All right? And then afterwards it has a1, or ai, excuse me, a subscript I. So a, in this case, is the term of an arithmetic sequence. Terms of arithmetic sequence, right? So what this is saying is it's saying add up the terms of an arithmetic sequence starting with I being 1. So if I is 1, that would be A1. And then keep adding them up until you get to n. So it'll be A1, and then I goes to the next number, A2, then A3, dot, 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 until you get to A, and then whatever number n is. In the problems, they will give you a number. They'll say add up the first 13 terms, or 14, or 118 terms, right? They'll put a number here, but this is a general formula that we can use for anything, and if we know n, we'll just plug it in, okay? So it's just saying it's adding up all the terms in arithmetic sequence, starting from the first one, going to whichever one I tell you. That's what this mess means. All right, let's look at this side. So this, if you want to do this, writing A1, let's even use a real sequence, right? Let's go back. What was this one? We're adding 13. So instead of doing 7 plus 13, no, excuse me, back up. 7 plus 20, whoops, undo. Plus 20, plus 33, plus 46, plus 59, dot, dot, dot. You could do it this way, but if n is 113, you're going to be so irritated with me at asking you to add 113 things together that you won't do it. I guarantee you won't do it. You barely even do 10 easy math problems for homework. You won't add up 113 things. The other problem with doing it this way, and I'm not trying to personally attack you here, but teenagers are not very good at using calculators, and they're not very good at not skipping a number in a list of 113 things. If I asked you to do this the hard way by typing it into a calculator, you would guaranteed mess this up and be off by like 12 or something like that. And you're thinking, no, not me, Mr. Barton. Okay, the other 31 of you would mess it up, and that one kid would get it right. But I used to give an example problem where I'd say, all right, find the sum of the first 50 terms, and then I'd give them the rule, right? Like start at 2 and add 4 each time, right? So it'd be 2, 6, 10, blah, blah, blah. I'd say add up the first 50 of them. And then I'd get like 4 or 5 different numbers as answers. I'd be like, so which one is it? And then everyone would be like, oh, I got the right one, right? Of course, only the kid who told me the wrong answer got the wrong one. But the point still stands, is doing it the long way is prone to errors. So someone figured out a formula that does the adding for you in a sneaky way. I'm not really going to explain where this formula comes from. If you really want to, you could beg me for it, and then maybe if you like donate $10 to the stream and subscribe to my Patreon, hit the subscribe button at the end, make sure you hit the bell icon for notifications, I'll explain it to you. But otherwise, this is just a formula that does that really tedious adding for you and tells you the right answer without all the mistakes. So let's break this thing down. N is whatever n is right there. It's the number of terms that you are adding up. 2 is the second natural number. 1, 2, there it is. A1 is the first number in a sequence. So if we have 1, 2, 3, 4, A1 would be this 1. It's the first number in your list. And then AN is the last number in the list. So if n was 100, we keep doing this, dot, 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 98, 99, 100. It would be that number right there. So you take the first number and the last number, you add them together, and then you multiply by n over 2. And then this thing will add up that big list for you. And this is the arithmetic series formula. Cool. In case you ever need to Google that thing again. I recommend you write this down somewhere that's going to be really easy for you to find when you're taking your test, because this thing is not written on the test anywhere. You have to go look through your notes and find this thing to be able to plug it in. And really, you just need that side right there. That's the formula you use. This side is just fancy math notation for mathematicians. All right. There's also another one for the geometric series. So this is just saying the sum of the geometric list starting at the first one, going to whichever one I tell you. So what you need for this one is obviously G1. So this is the first number again. You need to know R in 2 places. R is your common ratio, and that's the number that you are adding, or excuse me, not adding, multiplying by over and over and over and over. Isn't it interesting that D, your common difference, doesn't show up here? It doesn't matter what you're adding here, as long as you know the first one and the last one. Curious. And then N, of course, is your term number. This is whichever term you end on. So if I say find the first, how do you spell first? I can't talk and type or write at the same time. First 52 numbers. Then N is 52. All right. It's not the value of the 51st number. It's not GN. It's not whatever that number is. It's how many numbers you're adding together. Okay. Let's go look at some examples, because I don't think looking at these complex fractions with these funky Greek letters and stuff is going to make a whole lot of sense to all but the most genius of you. So let's go look at some concrete examples. So our first example is obviously arithmetic, because adding's a little easier. So it says find the sum of the first 14 terms in the following sequence. All right, here is our series formula. So let's figure out what we need to know. We need to know n. We need to know a1, which is the first number in the sequence. And then we need to know an, which is the last number in the sequence. So n is how many terms are we adding up? Well, it says right here, the first 14. So this is 14. That means we want a 14. What is the value of the 14th number in that list? The first number in that list is super easy to find. It's right there. It's the first number. So that's 9. Now we need to figure out what is the 14th number. To do that, you can either figure out the pattern and then just go out 14 numbers, or what I'm going to do is use the it's called the explicit rule. Not explicit like words that Lil Wayne says, but explicit as in it tells you the value. Use the explicit formula. And what that is it's the arithmetic formula you learned in the last set of notes. So it is an equals a1 plus d times n minus 1. So we're going to use this formula to find a14. So let's start by doing that. So a1 is 9 plus, what are we adding each time? Well, let's see, plus 4, right? Plus 4, let's just check. Plus 4 again, plus 4 again. So d is equal to 4 times n minus 1. We want the 14th term, so it'll be 14 minus 1, which will be 13. So this is 9 plus 4 times 13. 4 times 13 is 2, carry the 1, 52 plus 9. So our 14th term in this list is going to be 61. There we go. Now we have all the information needed to plug into our arithmetic series formula, not to be confused with the explicit sequence formula. So we're going to plug in these numbers. Scroll down so I got a little room to write. So we have n is 14 divided by 2 times the first number, 14, whoops, excuse me, bless you, plus, come on, plus 61. All right, so 14 divided by 2 is 7. And then 14 plus 61 is 75. And then you type that into your calculator, 7 times 75, and you get 525. So if we add up the first 14 numbers in this list, it will give us 525, in case you care. Why would you care about this? This is good for anytime your thing is growing at a constant rate. This could be like your money. If you get a job someday, not if, when, you'll all get jobs eventually. Hopefully you don't end up like homeless and starving, but you'll get a job someday, and then if you're salaried, your pay will never fluctuate. It's not like, well, I worked a little harder this week, so I made a little extra. You'll always get the exact same amount. So you're adding the same amount, D, to your starting amount of money every single 2 weeks. This could tell you how much money you're going to make over the course of a year. You could use this formula to figure that out instead of sitting and multiplying and doing a whole bunch of adding and stuff. So pretty nice, you know. All right, so there is our arithmetic series. Let's go do a geometric one just for completeness. That way we've got the full picture. So this is nice because there is no explicit formula required. We don't need to know the last term here. So whatever the 13th term is, I don't give a heck. You know what I mean? So we just need to figure out what is the first one, G1, what is our common ratio, or what are we multiplying by, and then how many of these numbers are we adding together. So our first number, G1, that's 4. You just look at the first number. N is telling us to add the first 13 terms. So N is 13. And R is the number we are multiplying by to get the next number each time. So to get R, we just take any number in the sequence and divide it by the previous number. So let's just take, I guess, 16, divide it by the previous number, -8. This is -2. So R is -2, and we're multiplying by -2 each time. All right. Let's plug these 3 numbers into this formula and then use our calculator to simplify. So we're going to have 4 times 1 minus -2 to the power of 13 divided by 1 minus -2. These parentheses, just in case you weren't paying attention in the last video, super important. If you don't have those parentheses, you'll get the wrong answer when you type it in the calculator because it will do 13th power to the 2 and then do something funny. You gotta, if you don't have these parentheses, sometimes you will get the wrong answer. And it's actually whenever you plug in a even exponent. So on this problem, it technically wouldn't matter, but we want to make sure we do it correctly regardless. So we're going to, first of all, I'm going to put this into the calculator just to start with, because I like to simplify stuff in chunks. So we're going to have 4 times 1 minus -2 to the 13th power is going to be negative 8,192 over minus a negative, same thing as plus, so 1 plus 2 is 3. Same thing up here, minus a negative is plus, so 1 plus 8,192, we have 4 times 8,193 divided by 3. So multiply the top, then divide by 3, and we get a total of 10,924. So if you add the first 13 numbers in this list, that's what you get right there. So there you go. There's your 2 examples. Hopefully that's enough. I made this a little weird by putting a negative sign on our common ratio. But if you need more help, or you say, Mr. Barton, you didn't show me one with a fraction, it's because I was trying not to scare you. But I recognize I may have done you a disservice. So please go into the WebEx. Let me know how irritated you are. Tell me, Barton, you're a real jerk. You know that? How dare you try and make me learn something so complicated as adding 13 numbers together? The audacity. And before you go, make sure you give this video a like. Make sure you hit the subscribe button. Click the bell icon for notifications. Share this with your mom. Maybe your dog. Maybe your friends who don't have such a caring math teacher to tell them how to add 13 numbers together. Have a good day, folks.